This chapter begins with a quick review of parallel, perpendicular, and skew lines. Our big focus this whole third unit is going to be in particular with parallel and perpendicular lines. So, parallel lines are two lines that are never going to intersect and they run along the same plane. So, we're looking at segment DH and we want to locate all parallel lines. So DH is parallel to CE. They're both going in the vertical direction. They will never intersect. DH is also parallel to AG. Notice that CE and AG are both along the same plane as DH. All right. Because AG is parallel to DH and BF is parallel to AG, by the transitive property, we can also say that BF is parallel to DH, even though they are not along the same exact plane. This is a cube, so that means that they form perpendicular angles. They meet at a 90-degree angle. So we have four perpendicular lines to segment DH. That is segment CD, EH, AD, and GH. Notice that all four of these lines intersect with our yellow segment DH. They all form a 90-degree angle. We are able to assume that these are 90-degree angles because this is a cube. And a cube, every single intersection of segments is at a 90-degree angle. And then our new vocabulary from this year was the word skew. Skew are lines that are never going to intersect with segment DH. However, they're not parallel because they're not along the same plane. So FG is an example of a skew line. They will never intersect. AB will never intersect. BC will never intersect. And neither will F to E. The main part of this unit where you're going to want to jot down notes of each of these different kinds of angles, we are looking at a transversal. So this red line here is considered our transversal. So it is a line that cuts through multiple lines. We're going to be looking at a transversal cutting through two lines, and they are our black lines. So the red line is our transversal. The black lines are just any two lines with the transversal cutting through it. If you notice, there are 8 angles that are formed. I'm going to number those. Angle 1, 2, 3, 4, 5, 6, 7, 8. So when a transversal cuts through, we'll call this angle line A and line B, it forms 8 pairs of angles. In the angles, we're going to look at angle relationships. Later on, when we look at parallel lines in particular, there's going to be certain rules or certain congruencies between these sorts of angles. But right now, we're just trying to recognize what are these different types of angle pair relations. So the first set of angles that we're going to talk about are called corresponding angles. Corresponding angles are within the same location. So what I mean by that is if I look at line A, in the upper left-hand corner is angle 1. For line B, in the upper left-hand corner is angle 5. Angle 1 and angle 5 is one set of corresponding angles. We have 3 more sets. Angle 2 for line A is in the upper right-hand corner. Angle 6 on line B is in the upper right-hand corner. Angle 2 and angle 6 are corresponding angles. In the lower right-hand corner is angle 3 for line A. For line B, the lower right-hand corner is angle 7. Angle 3 and angle 7 are corresponding angles. And then our last pair of corresponding angles are in the lower left-hand corner. So on line A, 4 is in the lower left hand, and for line B, 8 is in the lower left hand. Angle 4 and angle 8 are corresponding angles. The next set of angles that we're going to be talking about are alternate interior angles. So to alternate means that we're on opposite sides and we want to be on the interior. We have 4 interior angles, which means they're on the insides of line A and line B. Our interior angles are angles 3, 4, 5, and 6. To alternate means that they go on opposite sides and opposite lines of our transversal. So one pair of alternate interior angles that we have are angles 4 and angle 6. Notice that they are on opposite sides of the transversals. They're also on opposite lines of A and B. Our second set of alternate interior angles are 3 and 5. Alternate exterior angles are somewhat similar, except now we're looking at the exterior angles for line A and B. So our exterior angles are 1, 2, 7, and 8. And to alternate means the same thing as our interior angles. We want our angles to be on opposite lines and on opposite sides of the transversals. So one pair is angle 1 and angle 7. Our second pair is angle 2 and angle 8. Opposite sides of our red transversal, opposite lines of A and B. The last set of angles that we're going to look at are consecutive interior angles. So once again, they are on the inside. So we're looking at angles 3, 4, 5, and 6 because they are on the interior of lines A and B. But consecutive means that we want them to be on the same side of the transversal. So we have 2 pairs. Pair number 1 is 4 with 5. And pair number 2 is 3 and 6.